Hello everyone, so we will be looking at this problem, minimum index of a valid split. The number is 2780 and this is a daily Leetcode problem. So the problem statement says that element x of an integer array of length m is dominant if more than half the elements of array have a value of x. In this example, you can see clearly that 2 is the dominant because 2 is present 3 times and the length of the total array is 4. Okay, so 3 is greater than 4 by 2. Okay, so that's why 2 is the dominant element over here. Okay, so you are given a zero indexed array nums of length n with one dominant element. Okay, so there is one dominant element which is present. We have to split this into two arrays. Okay, two arrays like 1 comma 2 and rest 2 2, or like we can split like this, you see below, like either we can split from here into two parts, which becomes two arrays become 1 2 2 2 2, or we can split from here, it will become 1 comma 2 and 2 2, or we can split from here, it will become 1 comma 2 or 2. Okay, so these are the possible splits we can have because I is less than n minus 1, that's why we are not taking any empty subarray. Okay, and we have to tell the minimum index. Okay, minimum index at which both these arrays have the same dominant element. Okay, so in this case what is the dominant element? 1. In this case 2. So since these two dominant elements are different, right, so this cannot be the answer. Now in the second example, in this dominant element there is no dominant element. In the second example dominant element is 2, so again this cannot be the answer. In this the dominant element is 2, in this the dominant element is 2, so the answer will be the split where happened. Okay, the split happened at the second index. Okay, so 2 will be the answer, because what we have to find, we have to find the split such that in both of these arrays, the left subarray and the right subarray, we have the same dominant element which was present in the original array. Okay, so we have to find the minimum index. Okay, so minimum index of the valid split where the split can happen such that this condition holds true. So coming on to the second example also, right, we will try to split at every point. Okay, here we are trying to split at every point and see the dominant elements are same, no, dominant elements are same, no, here the dominant elements are same, no, here no, here yes. In this case 1 is the dominant element, on the left hand side also 1 is the dominant element, in the whole array 1 was the dominant element. So the minimum index will be 0 1 2 3 4, the 4 will be the minimum index of the valid split. Got it? Now there can be the case, right, that where there is no valid split, like in this case when wherever we are splitting, right, we are unable to find the dominant element. Okay, in both of these arrays. So in both of these arrays the dominant elements are not the same, both of these arrays dominant elements are not the same. So we tried splitting at every point, but the dominant elements were not the same. So let's understand how our algorithm will work. First of all, we have to find the dominant element. Dominant element which occurs more than half of the times. Okay. So for that, there is a very famous algorithm. Like one way of doing it is to maintain a map, okay, and maintain a counter for each of them, and then check which has the maximum counter. Okay. So that is one way, but that takes order of n space. Okay. So in order to avoid that order of n space, right, in order to perform the solution in order of n time and order of one space, there is a standard algorithm, okay, which says Boyer-Murray majority voting algorithm. Okay, so this is a famous algorithm, famous majority voting algorithm. So we'll look through it, like what does it say, and then once we have identified this, will what it will give us, it will give us the majority element, which in this case is 2. Okay, it will say that 2 is the majority element. Now we have to find that index. That is very simple. Okay, we will maintain the majority count on the left subarray and on the right subarray, like we are starting from here. Okay, so on the left subarray we will see that 1 equal to 2, no, so on the left it is 0, and overall we know we will keep on subtracting the majority count as we encounter this dominant element. We will keep on adding in the left subarray and removing from the right subarray, and this will be the condition, that is the dominant element count on the left subarray into 2 should be greater than elements on the left subarray count. Okay, that means the total number of elements which are present in the left subarray should be less than 2 times the dominant element count present in the left subarray. Okay, this is the condition for like occurrence of an element more than half their size on the left subarray. Similarly, on the right subarray also, we will check the same condition. That is that the number of dominant elements which are present in the right subarray multiplied by 2 should be greater than the number of elements which are present in the right subarray count. This condition is very important. Okay, this you will logically also find it that okay. So on the left subarray we have to find a dominant. On the right subarray we have to find a dominant. So this is the condition into 2 greater than this. Okay, so obviously, right, so dominant array when we multiply by 2 it will exceed the total size. Okay, so this is the obvious condition for that. So we'll return the I, otherwise we will return -1 if we are not able to find any index. Okay, so this will also be done in order of n time without any space. So let's look into the code. So first of all, we will apply this Boyer-Moore's voting majority voting algorithm. So what it says is we are maintaining the dominant element count and we are maintaining the dominant element. And then we are traversing over the whole array. We are saying that if the dominant element count is 0, okay, that means there is a potential that the current element is the dominant element. Okay, so we set the current element as a dominant element. And now we check that if the dominant element is equal to the nums I, then we will increment the count. But if it is less, then we will decrement the count. So what will happen is at the end of this array, right? So the dominant element count, okay, the dominant element count and the dominant element count will be greater than or equal to 0. Okay, it will be greater than 0. Okay, and there will be the element present over here in the dominant element will be the dominant element. Why? So if you will see over here, so the dominant element, since it is occurring greater than n by 2, so the net result of plus and minus will be net effect like plus only, and you will observe that whatever element which is present in the dominant element, right, so that dominant element will actually be our majority element. Okay, so the reason of this is because it is occurring more than n by 2 times. Okay, and we have put the condition over here that we are resetting only when it is 0. Okay, so at the end of this, the dominant element will always be the majority element. Okay, because count will always be 1 plus, because n by 2, more than n by 2 it will come, right? So we are incrementing it or decrementing it. We are incrementing it when it is coming. So it will come n by 2 plus 1 times, and rest of the elements are always less than n by 2, right? So they will never be able to they will never be able to reset the value, okay, for the dominant element. So that's why at the end the dominant element will be the majority element. Got it? So you just think over it, take some examples, then you will come to know like this is making sense. And why this is making sense, because of simple property that it is occurring n greater than n by 2 times, and the count will be like positive for that at the end of this for loop. Okay, so now let's look ahead. So now what we will do, once we have find the dominant element, now we have to see that what's the total count of that dominant element. Okay, so we will maintain, since we initially we will just have the right subarray, the left subarray will be like there will be no left subarray. Okay, so that's why we are we have named it like that, the dominant element present in the right subarray. So that we are keeping a count like this, and in the step 3 what we are doing is we are maintaining a count on the left subarray, and we are traversing from 0 till n nums dot size -1, because we are given that we can split till this point only. Okay, so the left subarray will be from 0 till I. Okay, that's from 0 to 0 or 0 to 1, and right subarray will be I plus 1 till n minus 1. Okay, n is nums dot size. Okay, so as soon as we find the dominant element, okay, so what we have to do, in the left subarray we will increase the count, okay, because we have encountered the left dominant element. In the right subarray, since we are including this nums I in the left subarray, right, we will decrement the count. Okay, so now what we will do is over here we will see that the same condition which I explained earlier, right, we know the left array, like how many elements are present in the left subarray, how many elements are present in the right subarray. So we know the how many dominant elements in the left subarray, how many dominant elements in the right subarray. So this is a simple condition of checking the majority. Into 2 should be greater than the number of elements on the left subarray, and dominant count on the right subarray into 2 should be greater than this. If both these conditions hold true, then only we will return that I. ith index. Okay, as soon as we get it, we will return it so that it is minimum. Okay, if we are unable to find it at the end, we are returning -1. Okay, so if you will see in this whole code, this is a complete code. Okay, these are the 3 steps. You will see that we are just applying for loops. There are 3 for loops. Okay, which is order of n time complexity. We are not doing any major operation inside the for loop, and we are not taking any space. So the space complexity is order of 1. Okay, so the time complexity is order of n, space complexity is order of 1. Thank you so much.